Introduction, Data-Informed Decision-Making. Scenario 1, Commercial Development Project. Project Overview. Project, construction of a $20 million commercial office complex. Duration, 24 months. Goal, to deliver a LEED Platinum certified building that sets a benchmark for sustainable construction in the Peninsula Bay Area. Application of data, daily integration of data. Eagle utilizes project management software, for example, Procore, Bluebeam, to track daily progress, monitor material deliveries, and communicate updates with stakeholders. Data in decision-making. Eagle analyzes historical project data to forecast material lead times, optimize construction schedules, and allocate resources effectively. Measurable metrics. Task progress. Monitor and report weekly on project milestones achieved against planned timelines using Procore. Numerical metric. Achieve 90% completion of structural framework by month 12. Quality assurance. Conduct bi-monthly quality audits to ensure compliance with LEED Platinum standards, aiming for zero non-conformances. Numerical metric. Maintain a defect rate of less than 1% in sustainable material installations. Safety metrics. Achieve a minimum of 98% safety compliance across all construction phases, measured through incident reports and safety training completion rates. Numerical metric. Complete 100% of safety training sessions with a participation rate of 95% among construction staff. Data-driven storytelling. Eagle presents quarterly reports to stakeholders, combining data on project progress, safety records, and sustainability achievements to illustrate the project's success story. Storytelling impact. Highlight a 20% reduction in carbon emissions compared to industry standards, showcasing the building's positive environmental impact. Scenario 2, Residential Renovation Project. Project Overview. Project, renovation of a historic residential estate. Budget, $3 million. Duration, 18 months. Goal, to modernize the estate while preserving its historical integrity and achieving LEED Gold certification. Application of data, daily integration of data. Eagle uses project management tools like Co-Construct and PlanGrid to manage subcontractor schedules, track material costs, and oversee renovation progress. Data in decision-making. Eagle leverages data from previous historic preservation projects to anticipate challenges in integrating modern features with historical elements. Measurable metrics. Historical preservation compliance. Achieve 95% success in integrating modern updates without compromising historical authenticity, verified through monthly progress reviews. Numerical metric. Complete 80% of historical facade renovations with approval from local historical preservation board by month 10. Customer satisfaction. Maintain a minimum of 90% satisfaction rate among homeowners through regular feedback surveys and post-renovation reviews. Numerical metric. Receive an average satisfaction score of 4.5 out of 5 in homeowner feedback surveys. Cost control. Achieve a 5% variance or less from the allocated budget, tracked through detailed financial reports and budget updates. Numerical metric. Complete 95% of renovation phases within budgetary limits as per quarterly financial audits. Data-driven storytelling. Eagle prepares a final project report showcasing data on renovation milestones, preservation achievements, and customer feedback. Storytelling impact. Illustrate how the integration of sustainable technologies led to a 30% reduction in energy consumption, benefiting both the environment and the homeowners. Benefits of data-informed decision-making. Improved efficiency. By leveraging data, Eagle enhances project management efficiency by 30% through optimized resource allocation and streamlined workflows. Risk mitigation. Data-driven insights enable Eagle to proactively identify and mitigate risks, resulting in a 20% reduction in project delays and cost overruns. Stakeholder confidence. Through data-driven storytelling, Eagle builds stakeholder confidence by demonstrating tangible project outcomes and adherence to high-quality standards. These scenarios not only showcase how Eagle applies data-informed decision-making but also provide measurable numerical metrics that illustrate the effectiveness of data utilization in achieving project goals and ensuring project success in the construction industry. In the scenarios involving Eagle the project manager and their commercial development and residential renovation projects, the application of data-informed decision-making is crucial across various stages and aspects of project management. Here's how each element of data utilization aligns with the broader principles outlined. Daily integration of data, commercial development project, application. Eagle utilizes project management software like Procore and Bluebeam to track daily progress, monitor material deliveries, and communicate updates with stakeholders. Significance. This integration ensures real-time visibility into project milestones, material availability, and stakeholder communication, enhancing overall project transparency and responsiveness. Residential renovation project, application. Eagle uses tools such as Co-Construct and PlanGrid to manage subcontractor schedules, track material costs, and oversee renovation progress daily. Significance. By leveraging these tools, Eagle maintains precise control over scheduling, costs, and project timelines, crucial for managing the complexities of integrating modern updates with historical preservation requirements. Data in decision-making, commercial development project, application. Eagle analyzes historical project data to forecast material lead times, optimize construction schedules, and allocate resources effectively. Significance: this data-driven approach enables Eagle to make informed decisions regarding resource allocation, mitigating risks associated with delays and ensuring efficient project execution. Residential renovation project, application. Eagle leverages data from previous historic preservation projects to anticipate challenges in integrating modern features with historical elements. Significance: by drawing insights from past projects, Eagle proactively addresses potential integration challenges, minimizing disruptions and preserving historical authenticity effectively. Measurable metrics, commercial development project, task progress. Eagle monitors and reports weekly on project milestones using Procore. Quality assurance, conducts bi-monthly audits to ensure compliance with LEED Platinum standards. Safety metrics, achieves a minimum of 98% safety compliance across all phases. Residential renovation project, historical preservation compliance, achieves 95% success in integrating modern updates without compromising historical authenticity. Customer satisfaction, maintains a minimum of 90% satisfaction rate among homeowners. Cost control, achieves a 5% variance or less from the allocated budget. Data-driven storytelling, commercial development project, application. Eagle presents quarterly reports combining data on project progress, safety records, and sustainability achievements. Storytelling impact, highlights a 20% reduction in carbon emissions compared to industry standards, demonstrating the project's environmental impact. Residential renovation project, application. Eagle prepares a final project report showcasing data on renovation milestones, preservation achievements, and customer feedback. Storytelling impact, illustrates how sustainable technologies led to a 30% reduction in energy consumption, benefiting both the environment and homeowners. Benefits of data-informed decision-making, improved efficiency. By leveraging data, Eagle enhances project management efficiency by 30% through optimized resource allocation and streamlined workflows. Risk mitigation, data-driven insights enable Eagle to proactively identify and mitigate risks, resulting in a 20% reduction in project delays and cost overruns. Stakeholder confidence, through data-driven storytelling, Eagle builds stakeholder confidence by demonstrating tangible project outcomes and adherence to high-quality standards. These scenarios illustrate how Eagle effectively integrates data at every stage of project management, from daily operations to decision-making and strategic storytelling. By leveraging data, Eagle not only ensures project success but also enhances stakeholder engagement and project outcomes in both commercial development and residential renovation contexts. Daily integration of data. Data is omnipresent in our daily lives, accessible through various devices like computers, tablets, and phones. We use it to track sports stats, monitor social media activity, and manage health metrics. Data in job search. Online job search platforms utilize data, for example, experience, location, qualifications, to match candidates with suitable job opportunities, demonstrating how data influences decisions by filtering out irrelevant options. Project data importance. In project management, data plays a crucial role in informing decisions and mitigating issues, both major and minor. It contributes significantly to achieving success metrics by analyzing metrics like tasks and issues. Types of project data. Common project data includes task progress, issue logs, and other metrics that impact project productivity and quality when analyzed effectively. Data-driven storytelling. Data is not merely numbers, it can tell a compelling story when combined with effective storytelling techniques. This approach persuades stakeholders by illustrating problem resolutions and ensuring project success. Benefits of data. Understanding data empowers project managers to make informed decisions, resolve challenges effectively, and ensure project success through evidence-based insights. This summary encapsulates the key points discussed in the introduction to data-informed decision-making, emphasizing its relevance and application in project management contexts. The value of data. Scenario 1, Commercial Office Complex Project Overview. Project, construction of a $50 million commercial office complex in Silicon Valley. Duration, 24 months. Goal, to deliver a LEED Platinum certified building that sets a benchmark for sustainable construction practices in the region. Application of data. Daily integration of data. Eagle utilizes project management software, for example, Procore, Bluebeam, to track daily progress, monitor material deliveries, and communicate updates with stakeholders. Data in decision-making. Analyzing historical project data to forecast material lead times, optimize construction schedules, and allocate resources effectively. Measurable metrics. Task progress. Monitor and report weekly on project milestones achieved against planned timelines using Procore. Numerical metric. Achieve 80% completion of structural framework by month 12. Quality assurance, conduct bi-monthly quality audits to ensure compliance with LEED Platinum standards, aiming for zero non-conformances. Numerical metric, maintain a defect rate of less than 0.5% in sustainable material installations. Safety metrics, achieve a minimum of 98% safety compliance across all construction phases, measured through incident reports and safety training completion rates. Numerical metric, complete 100% of safety training sessions with a participation rate of 95% among construction staff. Data-driven storytelling, Eagle presents quarterly reports to stakeholders, combining data on project progress, safety records, and sustainability achievements to illustrate the project's success story. Storytelling impact, highlight a 25% reduction in energy consumption compared to industry standards, showcasing the building's positive environmental impact. Scenario 2, Residential Renovation Project. Project Overview, Project, Renovation of a Historic Residential Estate in Palo Alto. Budget, $5 million. Duration, 18 months. Goal, to modernize the estate while preserving its historical integrity and achieving LEED Gold certification. Application of data, daily integration of data. Eagle uses project management tools like Co-Construct and PlanGrid to manage subcontractor schedules, track material costs, and oversee renovation progress. Data in decision-making, leveraging data from previous historic preservation projects to anticipate challenges in integrating modern features with historical elements. Measurable metrics, historical preservation compliance, achieve 95% success in integrating modern updates without compromising historical authenticity, verified through monthly progress reviews. Numerical metric, complete 85% of historical facade renovations with approval from local historical preservation board by month 10. Customer satisfaction, maintain a minimum of 90% satisfaction rate among homeowners through regular feedback surveys and post-renovation reviews. Numerical metric, receive an average satisfaction score of 4.7 out of 5 in homeowner feedback surveys. Cost control, achieve a 5% variance or less from the allocated budget, tracked through detailed financial reports and budget updates. Numerical metric, complete 90% of renovation phases within budgetary limits as per quarterly financial audits. Data-driven storytelling, Eagle prepares a final project report showcasing data on renovation milestones, preservation achievements, and customer feedback. Storytelling impact, illustrate how the integration of sustainable technologies led to a 35% reduction in water consumption, benefiting both the environment and the homeowners. Benefits of data-informed decision-making, improved efficiency, by leveraging data. Eagle enhances project management efficiency by 30% through optimized resource allocation and streamlined workflows. Risk mitigation, data-driven insights enable Eagle to proactively identify and mitigate risks, resulting in a 20% reduction in project delays and cost overruns. Stakeholder confidence, through data-driven storytelling, Eagle builds stakeholder confidence by demonstrating tangible project outcomes and adherence to high-quality standards. Additional context on data utilization. Introduction to data. Data serves as a collection of facts or information that, through analysis, facilitates informed decision-making and prediction. Daily use of data. In everyday scenarios, individuals like Eagle utilize data to enhance performance, such as tracking project progress and ensuring compliance with quality standards. Business perspective. Organizations harness data to optimize operations and innovate, akin to how Netflix predicts viewer preferences to enrich customer experiences. Project management application. As exemplified by Eagle, project managers leverage data to resolve challenges, enhance processes, and meet stakeholder expectations effectively. Power of data. Through rigorous analysis and application, data emerges as a potent tool for steering projects towards successful outcomes. Types of project data. Various forms of project data from progress metrics to customer feedback guide decision-making and project direction effectively. This comprehensive approach highlights how Eagle strategically applies data in construction project management, ensuring exceptional project delivery and stakeholder satisfaction. Introduction to data. Data is a collection of facts or information that, through analysis, helps draw conclusions and make predictions and decisions. Daily use of data. People use data daily to improve performance, such as a runner tracking their pace and performance using a GPS watch. Business perspective. Companies leverage data to improve operations and create value. For instance, Netflix uses data to predict viewer preferences and enhance customer experience. Project management application. As a project manager, data helps in making better decisions, solving problems, understanding performance, improving processes, and meeting user needs. Project example, Plant Pals at Office Screen, Customer Insights, using data on customer buying patterns to optimize plant orders and enhance product offerings. Process improvement, analyzing project tracker data to identify issues in internal processes and prioritize improvements. Power of data. Data, through critical analysis and application, becomes a powerful tool to steer projects towards success. Types of project data. The video sets up to discuss various types of project data that can be utilized to guide project direction effectively. This summary captures the essence of how data is utilized in project management, emphasizing its role in decision-making, process improvement, and overall project success. Common types of project data. Scenario 1, Multi-million-dollar commercial development project overview, project, construction of an $80 million commercial high-rise in Silicon Valley. Duration, 36 months. Goal, to deliver a LEED Platinum certified building that sets a benchmark for sustainable construction practices in the region. Application of productivity metrics. Milestones, identify and achieve critical project milestones such as foundation completion, structural framing, and interior fit-out stages. Numerical metric, complete 30% of structural framing by month 12. Tasks, track progress of essential activities like vac installation, electrical rough-ins, and exterior facade detailing. Numerical metric, ensure 95% completion of vac installation by month 24. Projections, use historical data to forecast project completion timelines and resource needs accurately. Numerical metric, predict project completion within a ±5% of plan timeline and budget by quarterly projections. Duration, monitor overall project timeline to ensure alignment with client expectations and contractual deadlines. Numerical metric, maintain project schedule with no more than a 5% variance in project duration milestones. Application of quality metrics, number of changes, document and manage changes in project scope to mitigate risks and maintain project alignment. Numerical metric, limit scope changes to less than 3% of the total project scope by quarter-end reviews. Issues, address and resolve critical issues impacting project progress such as permit delays or material shortages. Numerical metric, resolve 90% of critical project issues within 48 hours of identification. Cost variance, monitor expenses against budget allocations to control project costs effectively. Numerical metric, maintain a cost variance of less than 2% between planned and actual expenses on a monthly basis. Additional types of data, project management tools, utilize Procao for real-time project updates, Co-Construct for client communication, and Bluebeam for document management. Data analysis tools, employ Tableau to visualize project metrics and performance indicators for stakeholder presentations. Benefits of data utilization, improved decision-making, data-driven insights enable Eagle to make informed decisions, optimize resource allocation, and mitigate risks promptly. Enhanced efficiency, by leveraging project management tools, Eagle ensures streamlined workflows and efficient communication across teams and stakeholders. Client satisfaction, transparent reporting and adherence to quality and sustainability standards bolster client trust and satisfaction throughout the project lifecycle. Fictional details and measurable numerical data, environmental impact metrics, track metrics such as CO2 emissions reduction targets and waste diversion rates to meet LEED Platinum certification requirements. Numerical metric, achieve a 20% reduction in carbon footprint compared to industry benchmarks by project completion. Stakeholder engagement metrics, measure stakeholder satisfaction through regular feedback surveys and meetings. Numerical metric, maintain a stakeholder satisfaction score of 90% or higher throughout the project lifecycle. Safety metrics, monitor safety incidents and adherence to OSHA standards to ensure a safe working environment. Numerical metric, achieve zero lost time incidents over the project's 36-month duration. Conclusion, this detailed scenario illustrates how Eagle the project manager effectively utilizes various types of project data to manage a complex commercial construction project. By employing productivity and quality metrics alongside advanced project management and data analysis tools, Eagle ensures not only project success but also enhances operational efficiency and stakeholder satisfaction. The use of measurable numerical data underscores Eagle's commitment to delivering high-quality, sustainable projects while maintaining stringent budgetary and timeline controls. Productivity metrics, milestones, important points in the project schedule indicating progress or completion of phases. Tasks, activities that need completion within specified timeframes. Projections, predictions of outcomes based on current information. Duration, total time taken to complete the project, including milestones and deadlines. Quality metrics, number of changes, tracking changes in project scope to monitor risks and deviations from initial requirements. Issues, known problems that could hinder task completion or project success. Cost variance, comparison between planned budget and actual expenses incurred. Additional types of data, project management tools, tools like Workfront and Jira for tracking project activities and performance. Data analysis tools, tools such as Tableau for visualizing and analyzing project data effectively. Importance of data, data helps project managers monitor progress, assess performance, manage risks, and make informed decisions. Utilizing project management and data analysis tools ensures data is centralized and accessible for effective project oversight. This summary captures the essential types of project data discussed, highlighting their role in project management and decision-making processes. Review: Common types of data. Scenario 1, construction of a LEED Platinum certified commercial high-rise project overview. Project: construction of an $80 million commercial high-rise in Silicon Valley. Duration: 36 months. Goal: to deliver a LEED Platinum certified building that sets a benchmark for sustainable construction practices in the region. Application of productivity metrics. 1. Milestones. Description: milestones are critical points in the project schedule that denote progress or completion of phases. Example: use Procore to track and visualize milestones like foundation pouring, structural framing completion, and LEED certification submission. Numerical metric: achieve LEED certification submission milestone by month 24. 2. Tasks. Description: tasks are activities assigned to team members within specified time frames. Example: utilize co-construct to assign tasks such as rack installation, interior finishing, and landscaping. Numerical metric: complete 80% of landscaping tasks by month 30. 3. Projections. Description: projections help in predicting future outcomes based on current data. Example: employ Bluebeam to analyze project progress data and forecast project completion dates and budget adherence. Numerical metric: predict project completion within a ±3% of plan timeline and budget by quarterly projections. 4. Duration. Description: duration measures the total time taken to complete the project from start to finish. Example: use Sage 100 Contractor to monitor project duration and ensure alignment with milestones and contractual deadlines. Numerical metric: maintain project schedule with no more than a 4% variance in duration milestones. Application of quality metrics. 1. Number of changes. Description: tracks changes in project scope to manage risks and maintain alignment with initial requirements. Example: maintain a change log in plan to record and analyze scope changes and their impact on project timelines. Numerical metric: limit scope changes to less than 2% of the total project scope by quarter-end reviews. 2. Issues. Description: issues are real problems that may hinder task completion or project success. Example: use Jira to track and resolve issues such as material shortages or regulatory delays promptly. Numerical metric: resolve 95% of critical project issues within 24 hours of identification. 3. Cost variance. Description: illustrates the difference between planned budget and actual expenses incurred. Example: maintain a detailed budgeting spreadsheet to monitor costs and compare them against the actual budget allocations. Numerical metric: achieve a cost variance of less than 1.5% between planned and actual expenses on a monthly basis. Additional types of data. 1. Project management tools. Tools: Procore, co-construct, Bluebeam, PlanGrid, Sage 100 Contractor. Example: integrate these tools to ensure real-time project tracking, collaboration, and document management across all phases. 2. Data analysis tools. Tools: Tableau. Example: use Tableau for visualizing project metrics and presenting performance indicators to stakeholders effectively. Benefits of data utilization: improved decision-making. Data-driven insights enable Eagle to make informed decisions, optimize resource allocation, and mitigate risks promptly. Enhanced efficiency: by leveraging project management tools, Eagle ensures streamlined workflows and efficient communication across teams and stakeholders. Client satisfaction: transparent reporting and adherence to quality and sustainability standards bolster client trust and satisfaction throughout the project lifecycle. Review: common types of data. Milestone: critical points in the project schedule indicating progress or completion of phases. Task: activities assigned to team members within specified time frames. Projection: predictions of future outcomes based on current data analysis. Duration: total time taken to complete the project from start to finish. Number of changes: tracks changes in project scope to manage risks and maintain alignment with initial requirements. Issue: real problems that may affect task completion or project success. Cost variance: difference between planned budget and actual expenses incurred. This scenario demonstrates how Eagle, the project manager, effectively utilizes various project data types to manage the construction of a large-scale commercial high-rise, ensuring both operational efficiency and alignment with sustainability goals. Each metric and tool contributes to informed decision-making, efficient resource management, and overall project success. Metric milestone description: a milestone is a productivity metric. Milestones are important points within the project schedule that indicate progress and often signify when a team completes a deliverable or phase of the project. Example: a project manager might use a tool like Smartsheet to visualize where milestones fall within a project timeline. Metric task description: a task is a productivity metric. Project managers assign tasks to project team members for them to accomplish within a set period of time. Example: work management software like Asana can help project managers create and assign tasks. They can also generate reports to track their team's productivity over time. Metric projection description. A projection is a productivity metric. This metric helps you analyze current information to predict future outcomes. Example: a project manager might use a spreadsheet and its built-in charting tools to analyze current productivity data and make projections about future productivity trends. Metric duration description. Duration is a productivity metric. A project's duration is the total time it takes to complete a project from start to finish. Duration can also be used for tasks. Example: project management software can help project managers monitor the duration of a project alongside certain milestones. Metric number of changes description. Number of changes is a quality metric. Changes show any inconsistencies from the initial requirements of the project. Example: a project manager might use a tool like a change log or a spreadsheet to measure the number of changes from stakeholders and look for areas to improve communication. Metric issue description. An issue is a quality metric and is known as a real problem that may affect the ability to complete a task. Example: project management software like Jira and Workfront can generate reports that help project managers track both the number of issues and the team's ability to resolve them quickly. Metric cost variance description. Cost variance is a quality metric and illustrates the difference between the actual cost and the budgeted cost. Example: a budgeting spreadsheet can help a project manager log costs over time and compare them against the actual budget. Common data metrics for project management. Scenario 1, Productivity metrics. Project, residential housing development in Silicon Valley. Goals, complete 100 residential units in 12 months. Maintain a consistent task completion rate of 85% on time. Monitor and optimize task duration to meet project deadlines. Metrics, milestones. Milestone 1, foundation completion for all units by month 3. Milestone 2, framing completion by month 6. Milestone 3, interior finishings by month 9. Milestone 4, final inspections and handovers by month 12. 2. Smartsheet to visualize and track milestone progress. Tasks, average number of tasks per month, 500 tasks. Monthly task completion rate, target 85%. Example, 425 tasks out of 500 completed on time each month. 2. Assigner to assign and track tasks. Projections, forecasted completion rate, 90% task completion by month 8. Projections adjusted monthly based on current data. 2. Spreadsheet charting tools to analyze trends. Duration, total project duration, 12 months. Average task duration, 3 days per task. 2. Project management software to monitor project and task duration. Scenario 2, Quality metrics. Project, commercial office space development in San Francisco. Goals, maintain cost variance within 5% of the budget. Limit project changes to 10 major changes. Address all issues within 48 hours. Metrics, number of changes, major changes, target 10 changes. Current status, 6 changes. 2. Change log or spreadsheet to track changes. Issues, total issues reported, 50. Issues resolved within 48 hours, 45, 90% resolution rate. 2. Jira to track and manage issues. Cost variance, budget, $10 million. Actual cost, $9,800,000. Cost variance, 2% under budget. 2. Budgeting spreadsheet to log and analyze costs. Scenario 3, Happiness and satisfaction metrics. Project, high-end condo renovation in Palo Alto. Goals, achieve a customer satisfaction score of 8 out of 10. Ensure a 90% recommendation rate from customers. Metrics, customer satisfaction scores, survey responses, appearance, 8 out of 10, ease of use, 9 out of 10, likelihood to recommend, 7 out of 10. Overall satisfaction score, 8 out of 10. 2. Surveys to collect feedback. Happiness metrics, visual appeal rating, 8 out of 10. Ease of use rating, 9 out of 10. Likelihood to recommend, 7 out of 10. 2. Tracking revenue, customer retention, and returns. Scenario 4, Adoption and engagement metrics. Project, launch of a new construction management software. Goals, achieve a 70% adoption rate within the first 3 months. Maintain an engagement rate of 50% daily active users. Metrics, adoption, total users, 1,000. Users who accepted the invitation, 700. Adoption rate, 70%. 2. Tracking invitation acceptance and participation rates. Engagement, daily active users, 500. Engagement rate, 50%. 2. Monitoring daily usage rates and customer interactions. Stakeholder and team member engagement, meeting attendance, 95%. Email response rate, 90%. Level of input in discussions, high. 2. Tracking meeting attendance, email responses, and input levels. Application in project management. Using tools, Procore and Co-Construct, for tracking milestones, tasks, and projections. Tableau, for visualizing project metrics and data analysis. Making decisions, using the collected data to guide decisions. Optimizing resources based on performance metrics. Measuring performance against set goals. Key takeaway. Understanding and using data, metrics, and analytics are crucial for successful project management. Different metrics will be more important depending on the project's unique goals and stakeholder interests. The project manager utilizes these metrics to ensure their projects are delivered on time, within budget, and to the satisfaction of all stakeholders. These detailed scenarios using the project manager and Peninsula Bay Construction provide practical examples of how to apply various data metrics in project management to ensure successful outcomes. Common data metrics for project management. Benefits of analyzing data in project management: improve decision-making, enables better choices based on data-driven insights. Problem solving, helps identify issues and refine processes. Performance and process improvement, optimizes team efficiency and project outcomes. User understanding, enhances knowledge of user preferences and behaviors for better product offerings. Key concepts. Data, information, such as numbers and feedback about different project aspects. Metrics, measurements of data, defining key information to know about the project. Analytics, the process of using data to answer questions, find patterns, and predict outcomes. Productivity metrics. Milestones, important points in the project schedule indicating progress and completion of phases. Example, visualizing milestones using Smartsheet. Tasks, activities assigned to team members with specific time frames. Example, assigning and tracking tasks with Asana. Projections, predicting future outcomes based on current data. Example, analyzing productivity trends with spreadsheet charting tools. Duration, total time taken to complete a project or task. Example, monitoring project duration with project management software. Quality metrics. Number of changes, tracks differences from initial project requirements. Example, measuring changes with a change log or spreadsheet. Issues, real problems affecting task completion. Example, tracking issues with Jira or Workfront. Cost variance, difference between actual costs and budgeted costs. Example, logging costs in a budgeting spreadsheet. Happiness and satisfaction metrics. Customer satisfaction scores, measures user attitudes, satisfaction, and perceived ease of use. Example, collecting feedback through surveys or tracking revenue, retention, and returns. Happiness metrics, related to user satisfaction aspects like visual appeal and ease of use. Adoption and engagement metrics. Adoption, whether a product, service, or process is accepted and used. Example, tracking invitation acceptance and participation rates. Engagement, degree and frequency of product, service, or process use. Example, monitoring daily usage rates or customer interactions. Stakeholder and team member engagement, measures participation and communication. Example, tracking meeting attendance, email responses, and input levels. Application in project management using tools, integrating project management tools, for example, Procore, Co-Construct, to track milestones, tasks, and projections. Data analysis, employing tools like Tableau for visualizing project metrics. Making decisions, utilizing data to guide decisions, optimize resources, and measure performance. Key takeaway. Understanding and using data, metrics, and analytics are crucial for successful project management. Different metrics will be more important depending on the project's unique goals and stakeholder interests. Resources for further learning. A comprehensive guide to project management metrics. Data-driven project management, the 4 most important data points to look at. Project analytics, benefits, challenges, and first steps. Project analytics to improve project and portfolio decision-making. Productivity metrics, why they're important. 4 examples. Common data metrics for project management. There are many types of project data you can use to determine your team's progress and efficiency, evaluate the success of your project, and inform project decisions. While you don't need to be a data expert, knowing how to measure, track, and evaluate the right kind of data will help you deliver the most value and impact. This reading will recap some of the common types of data from the previous video and introduce a few more key data points that can help you manage projects and work with stakeholders. This reading will also introduce a few ways to interpret the data so that you can reduce risks and make the right decisions about your teams and projects. The benefits of analyzing data in project management. A hand pointing at one of the bars in a bar chart. As a project manager, you can use data daily to make better decisions, solve problems, improve performance and processes, and understand your users. For example, if you have data on customer buying patterns, you can identify your best-selling products, and you'll be able to make smarter decisions when placing new product orders with your suppliers. This data will also help you better understand your users and their preferences so you can improve your product offerings and performance. You can also use project team data to help you refine your processes. For example, if your team is experiencing an issue, analyzing data from your project tracker about the number of tasks completed, escalations, or internal process problems can help you find the source. This will allow you to make an informed decision about where to focus your efforts to improve processes. Through critical analysis, application, and execution, data becomes a powerful tool to guide any project in the right direction. Data, metrics, and analytics. 3 images to represent data, metrics and analytics. 3 images, numbers grouped in a circle to represent data. A graph with rulers lining the x and y axis to represent metrics. 2 people working on a puzzle to represent analytics. Data is information. It's the numbers and feedback available to you about different aspects of your project. Metrics are how you measure your data. They define the important or specific information, data, you need to know about your project, such as productivity, quality, or engagement. Once you determine your project's metrics, you analyze the data according to those metrics to find patterns and answer questions about your project. This process is called analytics, using data to answer questions, discover relationships, and predict unknown outcomes. When analyzing data, ask, what do the metrics mean to you? How do you want to use the metrics you've chosen? Can you find patterns to make predictions about your project? Can you find ways to improve or optimize certain aspects of your project? What lessons can you draw from your project's data? The next few sections are some common categories of metrics used in project management and a brief explanation of what they are and how they're useful to a project. Keep in mind that your use of different metrics isn't limited to these categories. All of your project data is interrelated. The same metric can also provide different information when applied to different aspects of your project. Productivity metrics. A calendar and clock to represent productivity. Productivity metrics typically measure progress and output over time. They allow you to track or predict the effectiveness and efficiency of your project team. To track your team's productivity over time, analyze the number of tasks or milestones completed in a given time frame. Ask questions like, what percentage of tasks are completed on time, and how long do they usually take? Or, if tasks were not completed on time, how much longer than anticipated did it take to complete all the tasks? On-time completion rates can help illustrate to clients and stakeholders how the project is progressing and when they can expect certain deliverables to be ready. If your project's completion rates are high, it means you're doing a good job of meeting your completion goals. If the rates are low, it means you're missing deadlines. Analyzing data can help you make decisions about things like improving or implementing new processes, or re-evaluating how you estimate project scope, complexity, and timeline. Calculating duration, how long something takes, can be useful for setting and evaluating tasks and milestones and determining if you'll meet project deadlines. Tracking task duration can improve the accuracy of estimating a project's timeline. This data is broken down into hours, days, weeks, months, and sometimes years. You can also analyze current information to predict future outcomes and make projections, or forecasts, about productivity trends, project durations, costs, performance or quality. This kind of data empowers you to proactively manage your project and its resources and measure the accuracy of your projections over time. For example, analyzing your team's overall performance or velocity can answer questions such as, is the team completing its tasks and milestones? What percentage of tasks is the team finishing on time? Predicting the future may be impossible, but building a better understanding of it and refining your method for making projections is achievable and valuable. Quality metrics. A clipboard with a check mark. Quality metrics relate to achieving acceptable outcomes and can include metrics such as number of changes, issues, and cost variance, all of which affect quality. Changes refer to differences in any aspect of the project from what was originally planned or required. Issues are problems that may affect task completion and often result in a change. Track the number of changes and issues to identify patterns, refine processes, and share information about the project with stakeholders. Cost or budget variance is the difference between the actual amount of money spent on a project and the amount that was budgeted for the project. Over time, this data can help you understand how well you're estimating budgets for your projects. A low variance means you've estimated your project budget accurately. A high variance means you should reevaluate your estimation process. You could be under or overestimating costs for your budget, or you may not be tracking expenses effectively. Happiness and satisfaction. 2 people smiling and giving a high five. Project managers at Google use a subset of metrics called happiness metrics that also relate to quality. These are metrics that relate to different aspects of the user's overall satisfaction with a product or service, like visual appeal, how likely they are to recommend, and ease of use. Happiness metrics can generally be captured with a well-designed survey or by tracking revenue generated, customer retention, or product returns. Customer satisfaction scores reflect user attitudes, satisfaction, or perceived ease of use. These scores measure how well the project delivered what it set out to do and how well it satisfies customer and stakeholder needs. Customer satisfaction scores generally represent a combined metric of the sum of several different happiness metrics. For example, on a satisfaction survey, a customer might separately rate a product's appearance as 6/10, ease of use as 7/10, and likeness to recommend or use again as 8/10. The overall customer satisfaction score would then be 7/10. You will need to determine what scores are acceptable for your project by discussing with stakeholders what the most important aspects of the project are. Adoption and engagement. A mobile device held by the user who is engaging with a website. Another set of metrics related to quality are adoption and engagement. Adoption refers to whether or not a product, service or process is accepted and used. Engagement refers to the degree to which it is used or the frequency of use, amount of time spent using it, and the range of use. It might help to think of these in terms of throwing a party. Your adoption metrics would reveal to you whether or not people accepted the invitation and showed up. The engagement metrics would tell you how active they were at the party or whether they participated in activities or interacted with other attendees, if they invited their friends to come with them, and how long they stayed. Adoption metrics for a product or service release, like an app, software program, delivery service, or gym membership, would be similar to the party example. However, they can be a bit more complex if you need to track metrics for more than one thing, like whether users make additional purchases or sign up for premium features. Each project will need to define its own set of successful adoption metrics, such as conversion rates, time to value, TTV, onboarding completion rates, frequency of purchases, providing feedback, rating the product or service, completing a profile. Engagement metrics tell you to what degree a product, service, or process is being used. They reveal the frequency and type of customer interaction and participation over time. Engagement metrics might include the daily usage rate of a design feature or tracking orders and customer interactions. As a project manager, you're not only concerned with the end user's level of engagement. It's just as important to monitor stakeholder and team member engagement as well. Measuring stakeholder participation by tracking the frequency of communication, responses to emails or updates, attendance at meetings, or level of input can give you a sense of whether or not stakeholders are finding value in the project. A lack of meaningful engagement could put your project at risk. Stakeholders may not be aware of changes or the overall progress of the project, and therefore the final outcome of the project may not meet their expectations. Measuring team member engagement is vital to the success of your project because the more engaged they are, the more productive they are, and the more likely they are to produce high-quality results. Ideally, you want your adoption and engagement metrics to increase or to at least meet the goal metrics that were established with stakeholders earlier in the project. If there is no increase, or the metrics drop, then your rates are low and therefore not as successful. Check out the resources below for a more in-depth understanding of how and why to measure adoption and engagement. Key takeaway: data, metrics and analytics are all important to the success of your project. You'll need to have some familiarity with how to collect and measure data, and how to use the data to tell you about different aspects of your project. Depending on the project and its unique goals, some metrics will be more important than others. It's your job to make sure you understand which metrics your stakeholders are most interested in and what elements impact your team's ability to deliver quality results on time and within budget. Want to learn more? Check out the following resources. A comprehensive guide to project management metrics. Data-driven project management, the 4 most important data points to look at. Project analytics, benefits, challenges and first steps. Project analytics to improve project and portfolio decision-making. Project management metrics. Productivity metrics, why they're important. 4 examples. A comprehensive guide to project management metrics. Project example, high-rise residential building in downtown San Francisco. Project goals, completed 20-story residential building within 24 months. Maintain a budget of $50 million. Achieve a customer satisfaction score of 90%. Detailed metrics and examples, schedule metrics, timeline tracking, milestone 1, foundation completed by month 3. Milestone 2, structure completed by month 12. Milestone 3, finishing touches completed by month 20. Tool used, Smartsheet for tracking milestones. Actual performance, foundation completed in 2.5 months. Structure completed in 11.5 months. Finishing touches completed in 19.5 months. Final delivery, planned completion, 24 months. Actual completion, 23 months. Variance, -1 month, ahead of schedule. Budget metrics, budget adherence, initial budget, $50 million. Final cost, $48 million. Variance, -$2 million, under budget. Cost variance, planned costs, $50 million. Actual costs, $48 million. Variance, -4%, under budget. Scope metrics, defined goals, initial goals, 200 residential units, underground parking, rooftop garden. Achieved goals, all initial goals met. Scope creep, initial scope, 100%. Final scope, 105%, due to additional requested amenities. Cost impact, additional $2 million covered within budget. Productivity metrics, efficiency measurement, inputs, 200,000 labor hours. Outputs, 200 residential units. Efficiency, 1 unit per 1,000 hours. Resource utilization, materials used, 95% of planned materials. Tool used, Procal for tracking resources. Return on investment, ROI, calculation, net benefits, $10 million. Costs, $48 million. ROI formula, ROI equals 10 divided by 48, x 100 equals 20.83%. Customer satisfaction, survey data, satisfaction score, 92%. Revenue impact, repeat clients, 5 new projects. Complaints, less than 2%. Actual cost, total expenditure, initial estimate, $50 million. Actual cost, $48 million. Schedule variance, timeliness, planned duration, 24 months. Actual duration, 23 months. Variance, -1 month, ahead of schedule. Cost performance, cost efficiency, earned value, $50 million. Actual costs, $48 million. Cost performance index, CPI, CPI equals 50 divided by 48 equals 1.04. Key takeaways from the scenario data utilization. Eagle effectively uses data and metrics to track and ensure project success. Customized metrics. Metrics were chosen to align with the project's specific goals and needs. Effective tools, Procore, Smartsheet, and Rike Analyze were instrumental in tracking and managing the project. Project success. The project was completed ahead of schedule, under budget, and with high customer satisfaction. By using detailed numerical metrics and real-world tools, Eagle ensures each project is managed with precision, leading to successful outcomes and continuous improvement in project management practices. Importance of project metrics evaluation. Metrics are crucial for understanding the success and viability of a project. Learning. Each project offers a chance to refine processes and drive better results through analysis. Benefits of using metrics: improve decision-making, data-driven insights help in making better choices. Problem-solving, identify issues and refine processes. Performance improvement, optimize team efficiency and project outcomes. Progress tracking, monitor ongoing progress to identify roadblocks early. Common types of project metrics: schedule metrics, timeline tracking, ensure tasks and milestones are achieved on time. Final delivery, confirm project completion on schedule. Budget metrics: budget adherence, stay within initial budget constraints. Cost variance, measure the difference between budgeted and actual costs. Scope metrics: defined goals, ensure clear project goals and deliverables. Scope creep, monitor for any deviation from the original plan. Productivity metrics: efficiency measurement, relationship between inputs and outputs. Resource utilization, maximizing output with minimum inputs. Return on investment, ROI, value versus cost. Calculate ROI using the formula, ROI equals, net benefits divided by costs, x 100. Customer satisfaction quality assessment, use customer survey data to measure satisfaction. Revenue impact, track metrics like revenue generated, repeat clients, and complaints. Actual cost total expenditure, sum of all costs incurred throughout the project lifecycle. Schedule variance timeliness, difference between budgeted and completed work. On-time performance, identify if the project is running late. Cost performance cost efficiency, ratio of earned value to actual costs incurred. Choosing the right metrics goal identification, determine project goals and success factors. Metric selection, pick metrics that align with project needs and objectives. Tools for tracking metrics. Right Analyze, provides reports and intelligence for tracking KPIs and project progress. Task management tools, use tools to monitor timelines and analyze performance. Key takeaways. Data utilization, understanding and using data, metrics, and analytics are crucial for successful project management. Customized metrics, different projects require unique metrics based on their goals and stakeholder interests. Skills, proficiency in Procore, Construct, Bluebeam, PlanGrid, and Sage 100 Contractor. Fictional scenario, high-rise construction project. Project goals, complete a 20-story residential building in downtown San Francisco within 24 months. Maintain a budget of $50 million. Achieve a customer satisfaction score of 90%. Metrics, schedule metrics, milestones, foundation by month 3, structure by month 12, finishing by month 20. Projections, regular updates on project progress using Smartsheet. Budget metrics, cost variance, monitor actual versus budgeted costs monthly with a variance of no more than 5%. ROI, calculate ROI with an expected net benefit of $10 million. Scope metrics, change log, track changes from initial requirements using a spreadsheet. Scope creep, ensure additional work requests do not exceed 10% of original scope. Productivity metrics, task tracking, assign and monitor tasks using Asana. Efficiency, achieve a productivity rate of 80% with minimum idle time. Customer satisfaction, survey results, collect feedback through quarterly surveys. Satisfaction score, target score of 90% by project end. Actual cost, expenditure tracking, use Sage 100 Contractor to sum all costs incurred. Schedule variance, on-time performance, identify delays and their impact on the schedule. Cost performance, efficiency ratio, calculate cost performance using earned value metrics. By utilizing these metrics and tools, Eagle can effectively manage the high-rise construction project, ensuring timely completion, budget adherence, and high customer satisfaction. Data-driven project management, the 4 most important data points. Overview. Eagle, a seasoned project manager in the construction industry, leverages data to optimize project outcomes. This fictional scenario will demonstrate how Eagle uses 4 key data points to manage projects effectively at their company, Eagle Construction Management. 1. On-time completion percentage. Definition, measures the percentage of tasks completed on time relative to the project schedule. Scenario, Eagle is managing a commercial office building project in Silicon Valley. The project has a scheduled timeline of 12 months with 200 tasks. Current metric, on-time completion percentage is 85%, 170 tasks completed on time. Importance, essential for client satisfaction and team morale. High percentage indicates good project estimation and task prioritization. Low percentage suggests issues in assessing team capacity and project difficulty. Improvement plan, training. Eagle organizes a series of training sessions to improve team efficiency and skill levels, focusing on project management software tools and best practices. Process enhancement, introduces a weekly review meeting to assess task progress and reallocate resources as needed. Estimation accuracy, implements a detailed pre-project planning phase, including thorough risk assessments and resource capacity evaluations. Target metric, 95%, 190 tasks completed on time. 2. Budget variance, cost variance. Definition, the difference between the budgeted cost and actual expenditure of the project. Scenario, the initial budget for the office building project is $10 million. Current metric, budget variance is plus 10%, $1 million over budget. Importance, critical for financial management and project success. Low variance signifies accurate cost estimation and resource management. High variance indicates flaws in the cost estimation process. Improvement plan, scope. Definition, Eagle revises the scope document to include all potential cost factors, such as unexpected material price fluctuations and additional labor. Detailed planning, maps out detailed project requirements, including a breakdown of all necessary components, like foundation work, framing, electrical, plumbing, and interior finishing. Budget revision, adjusts the budget to accommodate changes, incorporating a contingency fund of 15% to handle unforeseen expenses. Target metric, plus 5%, $500,000 over budget. 3. Number of errors definition, tracks the number of mistakes made during the project. Scenario, during the construction of the office building, errors such as misaligned structures and incorrect material usage have been reported. Current metric, 20 errors out of 150 completed tasks, 13% error rate. Importance, directly impacts on time completion and budget variance. Helps maintain quality by identifying areas needing improvement. Improvement plan, error tracking, uses Kanban boards within Procore to track task progress and identify error-prone stages. Process refinement, analyzes error trends and implements corrective actions, such as additional quality checks at key milestones. Training, conducts workshops focused on precision in construction techniques and materials handling. Target metric, 5 errors out of 150 completed tasks. 3% error rate. 4. Return on investment, ROI, definition, measures the profitability of a project relative to its cost. Scenario, the project is expected to generate $12 million in revenue upon completion. Current metric, ROI is projected at 15% due to higher than expected costs and delays. Importance, provides a comprehensive view of project success. Essential for evaluating projects with measurable outcomes like new product lines. Improvement plan, milestone tracking, regularly compares estimated time and costs against actual figures at each project milestone using Bluebeam. Real-time adjustments, implements real-time course corrections to mitigate cost overruns and delays. Client communication, maintains transparent communication with the client about progress and financial health, ensuring alignment and trust. Target metric, 20% detailed example with numerical metrics project, construction of Silicon Valley office building project duration, 12 months total tasks, 200 initial budget, $10 million expected revenue, $12 million key data points and actions on time completion percentage initial metric, 85%, 170 tasks completed on time, target metric, 95%, 190 tasks completed on time, actions, training sessions, weekly review meetings, and improved estimation accuracy. Budget variance initial metric, plus 10%, $1 million over budget, target metric, plus 5%, $500,000 over budget, actions, revised scope, detailed planning, and inclusion of a contingency fund. Number of errors initial metric, 20 errors out of 150 completed tasks, 13% error rate, target metric, 5 errors out of 150 completed tasks, 3% error rate, actions, enhanced error tracking, process refinement, and focused training. Return on investment, ROI, initial metric, 15% target metric, 20% actions, milestone tracking, real-time adjustments, and transparent client communication. Conclusion: Eagle's meticulous approach to data-driven project management helps ensure project success by focusing on key KPIs. Through strategic training, detailed planning, process enhancements, and real-time adjustments, Eagle improves on-time completion rates, controls budget variance, reduces errors, and maximizes ROI. These practices not only enhance project outcomes but also reinforce Eagle's reputation for excellence in the construction industry. Overview: Importance of data in project management, facilitates better decision-making. Focus on key data points to optimize project outcomes. 1. On-time completion percentage definition, measures the percentage of tasks completed on time relative to the project schedule. Importance, essential for client satisfaction and team morale. High percentage indicates good project estimation and task prioritization. Low percentage suggests issues in assessing team capacity and project difficulty. How to improve: implement training for staff. Enhance processes to maximize efficiency. Better estimate project scope and difficulty. 2. Budget variance, cost variance, definition, the difference between the budgeted cost and actual expenditure of the project. Importance, critical for financial management and project success. Low variance signifies accurate cost estimation and resource management. High variance indicates flaws in the cost estimation process. How to improve: ask the right questions to understand project scope before starting. Map out detailed project requirements. Revise budgets to accommodate changes during the project lifecycle. 3. Number of errors definition, tracks the number of mistakes made during the project. Importance, directly impacts on time completion and budget variance. Helps maintain quality by identifying areas needing improvement. How to track: use project management tools like Kanban boards. Monitor tasks as they move through different stages. Count tasks sent back for rework. How to improve: implement systems to reduce errors. Review and refine internal processes. 4. Return on investment, ROI, definition, measures the profitability of a project relative to its cost. Importance, provides a comprehensive view of project success. Essential for evaluating projects with measurable outcomes like new product lines. How to track, use project management tools to record time and expenses. Compare estimated time and costs against actual figures at each milestone. Adjust course in real time to protect ROI. Conclusion: importance of data in modern project management. Focus on key KPIs, on-time completion percentage, budget variance, number of errors, and ROI. Adjust project management strategies based on data insights to improve project outcomes. Project analytics, benefits, challenges, and first steps. Fictional scenario: Eagle, the project manager at Peninsula Bay Construction. Background: Eagle is a renowned construction project manager with over 15 years of experience, managing complex projects with precision and expertise. With a bachelor's degree in civil engineering and certifications including PMP, Eagle is known for delivering projects on time, within budget, and to high standards of quality and safety. Skills and expertise: project management tools, Procore, CoConstruct, Bluebeam, PlanGrid, Sage 100. Contractor. Client relationship management, effective communication and transparent project execution. Strategic vision, aligns project objectives with organizational goals. Ethical standards, upholds integrity and accountability. Leadership and management style. Eagle excels in motivating teams, fostering collaborative environments, and ensuring meticulous coordination from planning to delivery. Their proactive approach to problem-solving and decision-making is key to navigating challenges. Project management philosophy. Eagle's philosophy emphasizes meticulous planning, effective resource allocation, and compliance with industry standards, ensuring projects meet or exceed expectations. Continuous improvement is a core principle, driving Eagle to stay updated with the latest technologies and methodologies. Achievements and impact. Eagle has managed a diverse portfolio of projects across the Peninsula Bay Area, including multi-million-dollar commercial developments and intricate residential renovations. Their success is measured by high client satisfaction and strong stakeholder engagement. Future goals. Eagle aims to expand their impact in the construction industry, tackling new challenges and spearheading innovative projects. Committed to excellence and continuous learning, Eagle remains a driving force in shaping the future of construction project management in Silicon Valley, California. Fictional scenario examples. Example 1, benchmarking. Project, Peninsula Bay Mall construction. Initial budget, $20 million. Actual cost, $22 million. Cost overrun, $2 million, 10%, schedule, 24 months. Actual duration, 26 months. Delay, 2 months, 8.3%. Action, Eagle uses historical data from similar projects to benchmark performance and identify areas for improvement. Example 2, forecasting accuracy. Project, residential housing development. Planned units, 100. Forecasted completion, 18 months. Predicted delay, 2 months, based on current progress. Mitigation, adjust resource allocation to avoid delays, saving $500,000 in potential cost overruns. Example 3, time series analysis. Project, office building renovation. Trend identified, increased costs due to new safety standards. Impact, additional $300,000 in expenses. Action, implemented process adjustments to comply with standards without significant delays, optimizing cost management. Example 4, ad hoc analysis. Project, bridge construction. Issue, unexpected geological challenges. Data analysis, evaluated similar past projects to develop a mitigation plan. Result, reduced potential delays by 3 months, saving $1 million. Example 5, cognitive analytics. Project, smart city infrastructure. AI, ML insights, identified unknown risks related to underground utilities. Action, preemptive adjustments to project plan, avoiding potential $2 million in costs and 4-month delay. Conclusion: Eagle's expertise in leveraging project analytics transformed data into actionable insights, driving project success. By implementing practical steps and utilizing EPP software, Eagle ensures projects are delivered on time, within budget, and to high standards, enhancing overall project performance. Introduction. Capital projects often face cost and schedule overruns. Underperformance is common, impacting shareholder value. Leveraging data can help manage projects more effectively. What are project analytics? Systematic analysis of data to inform better decisions. Uses statistical models to gain key insights. Helps project managers stay on schedule and budget. Predictive capabilities for proactive issue management. A data problem equals a project analytics opportunity. Data creation has surged, with 40 trillion gigabytes existing. Capital projects generate vast amounts of data. 83% of engineering construction executives believe in a data-driven future. Current data utilization is inadequate, often only backward-looking. Status quo in project analytics: data is captured but not effectively utilized. Many companies do not have real-time insights. Reports are typically retrospective, lacking clear improvement paths. Consistently high performance requires better data leverage. Benefits of project analytics benchmarking: evaluate performance against internal, external datasets. Forecasting accuracy and predictability: identify issues early, allowing corrective actions. Time series analysis: identify trends and impacts of new standards, processes. Ad hoc analyses: answer specific challenges with data-backed decisions. 5 levels of project analytics maturity: descriptive analytics, basic, backward-looking reporting. Diagnostic analytics: analyze past performance to understand why events occurred. Predictive analytics: forecast future outcomes using past data. Prescriptive analytics: suggest actions based on predictive data. Cognitive analytics: use AI, ML to uncover unknown insights. Challenges in leveraging project analytics: siloed and inaccurate data, multiple tools lead to inefficiencies and errors. Unstructured data, difficult and costly to manage. Lack of good project controls and management foundation: technology alone isn't enough, best practices are essential. Practical steps to improve project performance with project analytics: define your vision, establish a comprehensive vision for data utilization. Adopt a foundational platform, centralize project data and processes. Start small, implement analytics in manageable iterations. Achieve quick time to value, deliver immediate business impacts. Make user adoption easy, ensure tools are accessible and intuitive. Build on your successes, use results to gain further buy-in and investment. How Enterprise Project Performance, EPP, software can help combines project portfolio management, controls, and management software. Centralizes project data, breaking down silos. Facilitates higher levels of project analytics maturity. Enhances insights and improves project performance. Project analytics to improve project and portfolio decision-making. Scenario 1, enhancing sustainability and efficiency in commercial construction project. Background: Eagle is overseeing the construction of a new LEED Platinum certified office building in Silicon Valley, spanning 100,000 square feet. The project aims to set new standards in sustainability and energy efficiency. Application of project analytics: Eagle employs advanced analytics to optimize project outcomes, energy efficiency metrics, implementing building information modeling, BIM, and energy simulation software to predict energy consumption. Targeting a 30% reduction in energy usage compared to conventional office buildings. Monitoring real-time energy performance metrics throughout construction using IoT sensors and smart meters. Cost control dashboards, utilizing integrated project management software to track daily expenditures against the $50 million budget. Aim for a variance of less than 3% by project completion. Forecasting cost trends and potential budget overruns using predictive analytics models based on historical data. Construction timeline prediction, leveraging historical project data and schedule optimization algorithms to predict a 12-month construction period. Targeting a completion window of 11.5 months, with a tolerance of ± week. Outcome: success metrics: achieved LEED Platinum certification, exceeding sustainability targets. Maintained a budget variance of 2.5%, $1.25 million. Completed construction in 11.3 months, 0.7 months ahead of schedule. Scenario 2, portfolio management for residential renovations. Project background: Eagle's company manages a diverse portfolio of residential renovations across the Peninsula Bay Area, focusing on quality and client satisfaction. Application of project analytics: Eagle implements portfolio management strategies enhanced by analytics, Client Satisfaction Index, CSI, conducting regular client surveys and sentiment analysis to maintain a CSI score of 95% across all renovation projects. Using sentiment analysis software to capture and analyze client feedback in real time, enabling proactive adjustments. Financial performance analysis, analyzing profitability margins for each renovation project using financial dashboard tools. Targeting a net profit margin of 22% on project costs. Implementing cost optimization strategies based on predictive analytics to reduce material wastage and procurement costs. Resource allocation optimization, utilizing workforce management software to optimize labor resources and schedule adherence. Targeting a 92% utilization rate for skilled labor. Outcome: success metrics, achieved an average CSI score of 94% across all projects. Maintained a net profit margin of 23.5% on project costs. Optimized labor utilization rate to 93%, reducing overtime expenses by 15%. Scenario 3, risk management and quality assurance in complex renovation projects. Project background: Eagle oversees a historically significant residential renovation project with stringent preservation requirements and tight deadlines. Application of project analytics: Eagle applies advanced analytics to manage risks and ensure quality assurance, schedule performance metrics, using earned value management, EVM, techniques to track schedule performance. Targeting an Earned Schedule Performance Index, SPI, of 1.15 to accommodate potential delays. Predicting schedule impacts using Monte Carlo simulations and scenario analysis based on risk register data. Risk register analysis, identifying and mitigating high-impact risks such as adverse weather conditions and supply chain disruptions using predictive analytics models. Aiming for an 80% risk mitigation effectiveness rate. Quality assurance metrics, implementing quality control dashboards to monitor compliance with preservation standards. Targeting a zero defect rate in critical preservation activities through continuous monitoring and corrective actions. Outcome, success metrics, achieved an earned SPI of 1.18, indicating effective schedule management. Mitigated 85% of identified high-impact risks, minimizing project disruptions. Maintained zero defects in critical preservation areas, ensuring adherence to historical authenticity. These scenarios illustrate how Eagle integrates project analytics into construction management, leveraging data-driven insights to optimize sustainability, client satisfaction, risk management, and project performance. Each scenario emphasizes measurable outcomes aligned with strategic goals, showcasing Eagle's commitment to excellence in project management. Theme: Project Management Leadership in a Rapidly Changing World. Keywords: Project Analytics, Commercial Vehicles, Project Dashboard, Portfolio Management, Decision-Making. Abstract: Project management faces increasing complexity due to shorter product development cycles, evolving customer expectations, and digitalization. Digitization with synchronized databases aids managerial decision-making through analytics, predicting and controlling project risks. Real-time updates enhance project team coordination and provide a comprehensive portfolio overview for strategic decisions. Introduction: Evolution of project management, from mid-20th century tools to modern digitization, integrating planning, control, and management to meet global competition and faster product delivery demands. Project analytics, definition: systematic quantitative analysis for improved decision-making, utilizing statistical analysis, Lean Six Sigma, and software programming. Purpose: unlike analysis, analytics projects future outcomes based on past performance, aiding proactive management. Prevailing practice at Mahindra Product Development System, MPDS, developed post-Scorpio launch, 2002, MPDS streamlined product launches, necessitating a centralized data warehouse. Digitization impact: integrating IT tools like SAP and Teamcenter addressed portfolio growth and project complexities. Application of project analytics for strategic management, tunnel vision versus funnel vision approaches. Tunnel vision, for short-duration projects with clear scope, digitization enables real-time data and quick decision-making. Funnel vision, long-duration projects benefit from early risk signals and decision-enhancing alternatives. Project selection and prioritization, dynamic portfolio management aligns new ideas with strategic priorities, informing decision-making. Focused dashboards for project visibility and control. Key dashboards: project budget dashboards, visualize budgeting and forecasting data. Project resource dashboards, track team workload and time utilization. Project deliverables dashboards, monitor progress with critical path and trend analysis. Improved project stakeholder management, real-time dashboards enhance stakeholder engagement and intervention through consistent updates and aligned communication. Predicting schedule delays and cost overruns, analytics predict schedule and cost impacts, aiding managers in keeping projects on track and within budget. Conclusion: strategic value, application of analytics in project management improves success rates and supports organizational goals. Mahindra's model, digitization exemplifies leveraging analytics to manage complexity and drive business success. This summary encapsulates how analytics and digital tools are transforming project management at Mahindra, enhancing decision-making and overall project success. Metrics for project management: how to measure track success. Scenario 1, residential construction project. Project name: Silicon Heights Residential Towers. Objective: construct 2 residential towers with sustainable features, ensuring high-quality finishes and timely delivery. Additional fictional details: Eagle, with his background in civil engineering and PMP certification, leads a team renowned for delivering complex construction projects in Silicon Valley. His meticulous approach and focus on sustainable building practices distinguish him in the industry. Metrics: productivity, metric, labor productivity target, achieve 90% efficiency in labor utilization. Measurement: calculate actual hours worked versus planned hours across all trades weekly. Example: labor productivity equals actual hours worked, planned hours, 100 gross profit margin. Metric: gross profit margin target, maintain a margin of 25% after accounting for all direct costs. Measurement: compare total revenue to total direct costs incurred. Example: gross profit margin equals total revenue, total direct costs, total revenue, 100 return on investment, ROI. Metric, ROI from sustainability features target, achieve an ROI of 15% from investments in sustainable building materials and energy-efficient systems. Measurement, calculate energy savings and increased property value against initial investment. Example, ROI equals, net benefits, costs, 100, earned value, EV, metric, earned value target, maintain F at 90% of planned budget at completion. Measurement, compare the budgeted cost of work performed, BCWP, to the budgeted completion, BAC. Example, earned value, EV, equals, BCWP, BAC, 100 customer satisfaction, metric, customer satisfaction index, CSI, target, achieve a CSI score of 85% based on client surveys. Measurement, aggregate scores from client feedback on project communication, quality, and timeliness. Example, CSI equals, total survey point score, total questions, 100. Scenario 2, commercial development project name, Bayfront Corporate Plaza objective, construct a LEED certified office complex with state-of-the-art technology infrastructure within budget and on schedule. Additional fictional details, Eagle's leadership in managing large-scale commercial projects is evident in his ability to integrate cutting-edge technology with sustainable design principles, ensuring optimal workplace environments for corporate clients in the Bay Area. Metrics, employee satisfaction score, metric, employee satisfaction index, ESI, target, maintain an ESI score of 90% throughout project phases. Measurement, quarterly surveys assessing team morale, work environment satisfaction, and communication effectiveness. Example, S equals, total survey point score, total questions, 100. Actual cost, AC, metric, actual cost target, manage project expenses within $5 million budget per phase. Measurement, track total expenditures against budget allocations per quarter. Example, AC equals total costs incurred cost variance, CV, metric, cost variance target, maintain a CV of ±5% against budgeted costs. Measurement, compare budgeted costs of work performed, BCWP, to actual costs of work performed, ACWP. Example, CV equals BCWP, ACWP schedule variance, SV, metric, schedule variance target, achieve an SV of ±5% for each phase compared to the planned schedule. Measurement, compare budgeted cost of work performed, BCWP, to budgeted cost of work scheduled, BCWS. Example, SV equals BCWP, BCWS cost performance index, CPI, metric, cost performance index target, maintain a CPI of 1.0 or higher indicating efficient cost management. Measurement, ratio of earned value, EV, to actual costs, AC. Example, CPI equals EV, AC. These expanded scenarios not only highlight Eagle's expertise in managing construction projects but also emphasize the strategic use of project management metrics to ensure success. Each metric is designed to measure key performance indicators critical to achieving project objectives, reflecting Eagle's commitment to delivering high-quality, sustainable projects on time and within budget. Importance of metrics. Metrics are essential for measuring and improving project management performance. They provide clarity and help in making informed decisions based on data rather than assumptions. Choosing metrics. To select appropriate metrics, understand the project's purpose and goals. Identify critical success factors necessary for achieving those goals. Define how each critical success factor will be measured. Characteristics of successful projects. A successful project delivers on time, stays within budget, achieves its predefined objectives, receives positive feedback from stakeholders and clients. Top 10 project management metrics. Productivity measures the efficiency of resource utilization. Gross profit margin indicates financial profitability after costs. Return on investment, ROI, evaluates benefits relative to project costs. Earned value, F, compares actual work completed to planned budget. Customer satisfaction, assesses satisfaction levels through surveys. Employee satisfaction score, measures morale and engagement. Actual cost, AC, total expenses incurred during the project. Cost variance, CV, compares budgeted costs to actual costs. Schedule variance, SV, compares planned versus actual progress. Cost performance index, CPI, measures efficiency of work completed relative to costs. Definitions and frameworks, metric versus KPI. Metrics are measurable units. KPIs are specific metrics used to gauge performance against objectives. OKRs, objectives and key results, goal-setting framework for clarity and alignment. Critical success factors, essential areas to measure project success, including benefits, time, cost, scope, quality, and risks. Purpose of metrics. Metrics provide evidence of project value, guide performance improvement, and aid in strategic decision-making. This summary captures the core concepts and metrics discussed in the document, focusing on how each metric contributes to assessing and enhancing project management effectiveness. Metrics for Project Management, How to Measure Track Success. Adobe Communications Team. The 18th of March 2022. 10 Project Management Performance Metrics. Measurement really is key to successful project management. As the old adage says, you can't manage what you don't measure. Collecting and measuring data is at the heart of any worthwhile endeavor. For project management evaluation, you can use project management metrics and key performance indicators, KPIs, to help you strategically meet your business goals and assess the success, or failure, of any project. Explore important metrics for project management in this guide. In this Project Success Metrics Guide you will discover: why use project management metrics? How do you choose metrics? What makes a successful project? 10 project management metrics definitions: metric, KPI, OKR, objective, KPO, goal, MBO. What are the project management critical success factors? Frequently asked questions. Why use project management metrics? Relevant project management metrics will enable us to improve our understanding by removing uncertainty so that we can make well-informed decisions. Metrics prove value. Project management metrics related to costs can prove the value of a team. For example, an on-time delivery rate or the rate of meeting SLA. Return on investment, ROI, is a widely used metric to show this value. If a department does not produce or contribute to the measurable objectives of a company, a smart company would dissolve the department and move resources to another area that produces results. Metrics improve performance. While proving value is important, forward-thinking management places more value on improving performance. Relevant metrics enable you to improve your understanding of project management. This removes uncertainty so that all involved parties can make well-informed decisions. For example, if the allotted slack time is delaying subsequent task completion, you can make adjustments in slack time, so the project completion date is not at risk. How do you choose metrics? Each business or project requires unique metrics that align with its purpose or goal. There are 3 steps to choosing metrics. Understand the purpose or goal of the project or work. Determine what critical success factors need to be fulfilled for you to succeed and achieve the goal. Take each critical success factor for the project or program and identify how you will measure its fulfillment. White paper, measuring and analyzing work. Learn more, Workfront for project management. What makes a successful project? Before starting any project, you and your team should have a clear understanding of what makes a successful project. You don't want to end up with a famous failed project after all. What defines a project that can be considered a success? You should have a series of success factors to score your project against, including that it delivers on time. Completing a project on time, to deadline, is one benchmark of success, especially if it's for an external party, such as a client. Stays within budget. All projects have a budget in place. If you can complete yours without running into extra costs and expenditure, that's a definite measure of success. Achieves its objectives. If your project has been completed and achieved its objectives as detailed at the very start of the process, that's a big win. Gets positive feedback. It's easy to evaluate the success of a project yourself and internally. But how was it received? If stakeholders and clients provide good feedback, the project should be seen as successful. 10 project management metrics. If you're just beginning to measure performance, get started with these 10 project management metrics to help drive success. Productivity, gross profit margin, return on investment, earned value, customer satisfaction, employee satisfaction score, actual cost, cost variance, cost performance. 1. Productivity. This metric looks at the overall capabilities of a company, how well it uses its resources. Productivity shows the relationship between inputs and outputs. How much are you getting out, after all that you put into a project? The ideal productivity outcome is creating more for less. Productivity equals units of input, units of output. 2. Gross profit margin. Numbers speak louder than words. Metrics directly tied to the bottom line communicate success or failure more quickly than other metrics. The higher the margin, the better the business is doing. Any program or work performed should contribute to the financial profit of a business. Margin is the percentage of each dollar earned after costs have been subtracted. Gross profit margin equals total profit total costs / 100. 3. Return on investment, ROI. Return on investment specifically looks at the dollar amount earned for the amount invested in a project. Like gross margin, this is a financial equation. Instead of looking at overall profit, it looks at the specific benefit from the project divided by the costs. To use this metric, a dollar amount needs to be assigned to each unit of data to determine the net benefits. Say benefits may include contribution to profit, cost savings, increased output. Costs may include resources, labor, training, and overhead. ROI equals net benefits, costs, x 100. 4. Earned value. Earned value provides strategic guidance by showing how much value you have earned from the money spent to date on a project. It compares the value of the work completed by a specific date in relation to the approved budget for the project. Earned value is also called budgeted cost of work performed, BCWP. This metric provides a reality check during the process of a project. Earned value, F, equals % of completed work, budgeted completion, back. 5. Customer satisfaction. A customer satisfaction score provides a measure of quality for your service or product. Customer survey data results guide this metric. The Center for Business Practices outlines this as a score on a scale from 1 to 100. The product or service should do what it was meant to do and satisfy real customer needs. Each company can develop a score unique to its business by weighing each variable based on its importance. Variables may include customer survey results, revenue generated from clients, repeat or lost clients, and complaints. The Customer Satisfaction Index, CSI, is the most widely used system for measuring customer satisfaction. The Net Promoter Score, NPS, is another method to capture customer satisfaction. NPS reveals customer loyalty by probing the likelihood of a customer recommending the product or service. Customer satisfaction score equals total survey point score, total questions, x 100. 6. Employee satisfaction score. Similar to customer satisfaction, survey data determines the employee satisfaction score. Why should you look at employees in measuring project management? The answer is pretty simple and obvious. Employee morale is directly correlated to project success. Here are 4 tips to measure morale. The bottom line is that a satisfied employee creates better work more efficiently. The high costs of employee turnover for a business, totaling 50% to 200% of an employee's salary, should be motive enough to pay attention to the people closest to the project. The Gallup Q12 Employee Engagement Survey is a popular tool to collect employee data. An Employee Satisfaction Index, ESI, processes results into an index score. Employee satisfaction score equals total survey point score, total questions, x 100. 7. Actual cost. The actual cost is a simple number that shows how much money is actually spent on a project rather than just an estimate. This cost is determined by adding up all the expenses for a specific project over the timeline. Actual cost, AC, equals total costs per time period x time period. 8. Cost variance. Cost variance shows the difference between the planned budget and actual costs within a specific time frame. Is the estimate above or below the actual costs? A project is over budget if the cost variance is negative. A project is under budget if the cost variance is positive, a typical measure of success. Cost variance, CV, equals budgeted cost of work, actual cost of work. 9. Schedule variance. Schedule variance looks at budgeted and scheduled work. Is the project running ahead or behind of the planned budget? The schedule variance is the budgeted cost of work performed minus the budgeted cost of work scheduled, the difference between work scheduled and completed. A negative schedule variance means the project is behind schedule. Schedule variance, SV, equals budgeted cost of work performed, budgeted cost of work scheduled. 10. Cost performance. Cost performance is a cost efficiency metric. Divide the value of the work actually performed, earned value, by the actual costs it took to accomplish the earned value. Forecasting cost performance allows for accurate budget estimations. Cost performance index, CPI, equals earned value, actual costs. Measuring project manager metrics. To excel as a project manager, you need to do more than inspire and motivate the team around you. Ultimately, the proof is in the results our manager needs to achieve and exceed business goals. Measuring project management metrics and agile metrics propel performance by creating checkpoints during the process to continually improve. Project management metrics. Learn more. Workfront for project management white paper. Deliver a 300% higher ROI on your SaaS purchase. Definitions: metric, KPI, OKR, objective, KPO, goal, MBO. Many words and phrases are used interchangeably in the business world, but at a certain point, we must refer back to their true definitions to get clarity about what's really being said. So, to hold meaningful conversations about your company's true aim, you'll need the proper knowledge about how to use the following terms correctly. This quick guide to definitions of metrics in project management should help. Metric. A metric is a quantifiable unit of measurement that tracks and or gauges the status of a particular process. In terms of project management, metrics are measures of assessing performance as mentioned in the section above. These include productivity, gross profit margin and more. KPI. KPI stands for Key Performance Indicator. A KPI is a metric of performance and determines if you are achieving success in an organization. KPIs are used as indicators that look backwards in most contexts. KPIs can also be found inside a key result in an OKR. Learn more about the difference between OKRs and KPIs. OKRs. OKR stands for Objectives and Key Results. It is a goal-setting framework that helps create clarity, focus, transparency, engagement, and alignment. This is through organizing predetermined objectives and the key results or the metrics that show progress towards the objective. Some of the world's best-known companies, including Google and Amazon, use OKRs. Objective. The O in OKRs are the thing to be accomplished that should be specific, measurable, time-bound, and ideally, quantifiable. An objective should detail what you want to achieve. There can be more than one objective within project management, though each has 1 to 3 key results. KPOs. Where KPIs are a metric, a KPO, Key Performance Objective, represents an objective you hope to achieve. KPIs are a series of specific measurement tools and goals, aimed at ensuring every detail of a project is met and achieved. Goals. Goals are longer range and broader than objectives. They are typically set in the context of a 3 or 5 year aspiration. Goals are meant to be broad for a time frame that extends beyond the period of 1 year. They can be broad and general and do not require quantification or a specific deadline. MBO. MBO stands for Management by Objectives. It is an approach to business management that was first introduced by father of management Peter Drucker in the 1950s that encompasses manager-team collaboration to establish short-term goals. The MBO process involves 5 steps: What are critical success factors in project management? Here are 6 factors that managers can measure to create metrics that determine project success. Benefits resulting from the capability delivered by a project: time, schedule to deliver project output, cost to deliver project output, scope of work to deliver project output, quality of deliverables and quality of process, customer satisfaction, risks including uncertainty or threats to project success. When a measurable goal is not met, you need to make changes. When a goal is exceeded, you can repeat successful processes. So, step on the scale and take an inventory of your current status. Determine which project management metrics will best guide your business goals and then get to work. Frequently asked questions about success metrics for project management. What are project metrics? A project metric is a way of measuring the success of a project. Typical examples of metrics include the expected cost of the project, duration of the project, time it will take to complete, and value of it. Each project will also have specific metrics too, though. Why are project metrics important? Project metrics are important because they enable you to accurately assess the success of a project against real, quantifiable goals. This is particularly important when reviewing a project and reporting on it to stakeholders. Project metrics also help with the learning process ahead, planning the next project. What worked well, and what didn't? What are project KPIs? Key performance indicators, KPIs, are a series of performance-linked goals throughout a project. These are yours to set, for each project. Typically KPIs tend to fall under 4 main categories, which are timeliness KPIs, budget KPIs, quality KPIs, effectiveness KPIs. Any number of specific criteria of assessment can be included in each. Productivity metrics, 4 practical ways to track success. Scenario 1, plan-to-done ratio. In construction project management context, Eagle, the project manager, oversees a large-scale commercial construction project in Silicon Valley. Objective, measure the plan-to-done ratio to assess operational efficiency and planning effectiveness. Metric, plan-to-done ratio definition, percentage of planned tasks completed compared to those scheduled. Numerical example, planned tasks, 100 construction milestones scheduled for completion in a quarter. Completed tasks, 85 milestones achieved by the end of the quarter. Calculation, plan-to-done ratio equals 85, 100, 100 equals 85%. Insight, an 85% ratio indicates effective planning execution with room for improvement in meeting all project milestones on time. Scenario 2, first call resolution. In construction project support context, Eagle's construction management firm implements a customer support system for client inquiries and project updates. Objective, track first call resolution to gauge service quality and operational efficiency. Metric, first call resolution definition, percentage of customer inquiries resolved on the first contact. Numerical example, total inquiries, 150 customer inquiries received in a month. Resolved on first contact, 120 inquiries resolved during the initial interaction. Calculation, first call resolution equals 120, 150, 100 equals 80%. Insight, achieving an 80% first call resolution rate indicates efficient customer service handling, enhancing client satisfaction and operational efficiency. Scenario 3, customer satisfaction. In residential renovations context, Eagle's team manages residential renovation projects across Silicon Valley neighborhoods. Objective, assess customer satisfaction to influence retention rates and brand reputation. Metric, customer satisfaction definition, measurement of customer happiness through post-project surveys. Numerical example, survey responses, 80 clients provide feedback post-renovation. Average satisfaction score, 4.8 out of 5, converted to percentage. Calculation, customer satisfaction equals 4.8, 5, 100 equals 96%. Insight, a 96% satisfaction score signifies exceptional client approval, reflecting superior project delivery and strong customer relationship management. Scenario 4, revenue per employee. In project development context, Eagle's firm expands its team to manage increasing project demands in Silicon Valley. Objective, calculate revenue per employee to measure overall team productivity and efficiency. Metric, revenue per employee definition, calculation of revenue generated per team member annually. Numerical example, annual revenue, $15 million generated by the construction division. Total employees, 75 members in the construction team. Calculation, revenue per employee equals $15 million, 75 equals $200,000 per employee. Insight, a revenue per employee of $200,000 underscores efficient resource utilization and high productivity levels, driving sustainable business growth. Conclusion: these detailed scenarios exemplify how Eagle, the project manager, leverages productivity metrics across various facets of construction project management. By employing these metrics with precise numerical examples, Eagle optimizes operational efficiency, enhances service quality, boosts customer satisfaction, and ensures robust team productivity. These practices not only reinforce Eagle's reputation as a leader in construction management but also contribute to sustained success in Silicon Valley's competitive market. Purpose of productivity metrics. Productivity metrics are crucial for measuring and improving how efficiently teams complete tasks and achieve goals. They provide insights into performance gaps and areas for improvement. Challenges addressed. Many companies face organizational drag, which can hinder productivity by consuming significant resources. Metrics help in identifying and mitigating these barriers. Definition of productivity metrics. These metrics quantify the relationship between resources applied, inputs, and outputs produced, enabling objective assessment of team efficiency. Benefits of measurement. Productivity metrics enable managers to provide specific feedback based on quantifiable data, fostering a culture of accountability and performance improvement. Examples of productivity metrics. Planned-to-done ratio measures the percentage of tasks completed compared to those planned, indicating operational efficiency and planning effectiveness. First call resolution tracks how often customer inquiries are resolved on the first contact, reflecting service quality and operational efficiency. Customer satisfaction assesses customer happiness through surveys or feedback mechanisms, influencing retention rates and brand reputation. Revenue per employee calculates the amount of revenue generated per team member, indicating overall team productivity and efficiency. Measurement process. Measuring productivity involves selecting relevant metrics aligned with business goals, collecting data consistently, and analyzing trends over time to identify performance patterns and areas needing improvement. Practical applications. Examples include tracking email efficiency, evaluating customer support interactions, and assessing revenue generation per employee across different industries. Strategic impact. Effective use of productivity metrics empowers organizations to optimize resource allocation, enhance operational efficiency, and drive sustainable business growth. This summary encapsulates the key insights and practical applications of productivity metrics as outlined in the article, emphasizing their role in fostering a productive and efficient workplace environment.